Secant is the same as what? 1 over cosine, right? So this is the same as saying 1 over cosine. So do you agree that secant is going to have asymptotes? And it's actually going to have asymptotes the same as which function, tangent or cotangent? Tangent or cotangent? Which one has cosine in the bottom? Tangent. So secant and tangent are both going to have asymptotes in the same place, wherever cosine is equal to 0. And cosine is equal to 0 when y is 0. Just kidding. When x is 0, which is up on the y-axis, right? So that would be at values like negative pi halves, 3 pi halves, just like we did yesterday with tangent. Which means, just like with tangent and cotangent, my advice to you is, step 1, we're going to find our asymptotes, and then we can graph points in between there. So, just like yesterday, I'm going to make my graph here, 2 pi. Let's just go up, just like we did yesterday, except 3 or 4. And we can draw our asymptotes in. At negative pi halves, at pi halves, at 3 pi halves. Again, those should be equally spaced, but mine aren't so good. And I want to figure out what's happening in between there. The bad thing about secant and cosecant is that maybe the numbers aren't going to be as pretty as tangent, but I'm going to hopefully show you a little shortcut here in a minute to help us. But let's just look between our first two asymptotes here. And I'm going to pick halfway in between just like I did yesterday. So I'm going to pick 0. And I'm going to plug in 0 up here. And you can think of secant of 0 if you want. I do better thinking of it as 1 over cosine of 0. What is the cosine of 0? Right, we should really be getting pretty good at this. These are my points that I'm picking every time on my unit circle, or like the main ones here, right? My ordered pairs, 1, 0, 0, 1, negative 1, 0. I'm not sure what happened there. 0, negative 1. You have to know that cosine is x and sine is y. If you don't know that, you're not going to be able to graph very well. At 0, what is the cosine? 1. So 1 over 1 means that that's at 1. So at 0, it goes up to 1. With cosine, at 0, does it usually go up to 1? Yeah. What other points could we pick? We could pick halfway in between again. We could pick pi halves. It's going to be a decimal, but we can use our calculator here. Sorry, pi fourths I meant. It's going to be a decimal. Are most of these going to be decimals that I pick here? Are you okay if we just pick some decimals here? Let's pick pi fourths. What's the cosine of pi fourths? Square root of 2 over 2, which means I have to flip it over. So without even simplifying it, square root of 2 over 2, do you agree that that would be 2 over square root of 2? If I just flip that over. Can we just type that in our calculator and get what decimal that is? So I can know where to graph it, roughly speaking. It's just hard to bend over. I'd rather just leave it there. You get about 1.41. Right? At pi fourths, it's square root of 2 over 2. Right? For cosine. So if it's secant, I'm just going to flip it over. So it's 1 over that. And we could simplify that, but I don't really care because I'm just trying to graph the decimal. Which means I could say that it's, at pi fourths, it's like, I don't know, about right there. That's right. I'll be lenient when I grade yours, if you're lenient when I'm doing it up here. What if I go the other way? What if I go to negative pi fourths? It's going to be down here in quadrant 4. It's definitely going to be the same decimal, right? Is it going to be, is it positive down there in quadrant 4? Is cosine positive in quadrant 4? Yes, because it's the x. So it's also 1.41, which means it's also about right there. And we could keep picking a bunch of points here, but again, the asymptotes kind of help me. This is kind of going to just look like a parabola going up. So when I graph this, it kind of looks like this, and like this. What happens if I go over here to pi, like the next asymptote, halfway in between? Is it going to be the exact same thing? Is it going to go up there? Because what is the cosine of pi? Oh, I just did. It's negative 1. So instead of going up here, it's going to go down here. And if I pick those halfway points in between, do you agree I'm going to be at the fourths again? I'm going to be at 3 pi fourths over here and then 5 pi fourths over here. The good news is we've already done the decimals here. We just got to figure out the signs. In quadrant 2, is cosine positive or negative? So do you agree it's going to be the negative 1.41? Because it's still square root of 2 over 2 flipped over. What about in quadrant 3, is cosine positive or negative? Also negative 1.41. So what happens? Yeah, it's kind of like a parabola going down. You can take it again. What's the period of cosine? Like just regular cosine, what's the period? 2 pi over b, or just 2 pi. It's going to be the same thing with secant. It's going to have a parabola going up, a parabola going down, and then guess what happens over here? It's just going to start repeating again, which means this side would be at 2 pi, it's going to go back up to 1, and this would be kind of like half of a parabola over here. And we can pick all these points and do it again if you want. What I want to show you is if you know what cosine looks like, you know what secant looks like. So, just a little jog your memory here. If I graph just cosine here, do you agree that at 0, cosine goes up to 1? And then at pi halves, cosine goes back to 0? Yes? And then at pi, it goes down to negative 1. And then back to 0. And then back up to 1 if I kept going there. And it kind of goes down like this. And it kind of keeps going like this. Do you see how, like, at every little turn on cosine, it's just flipped over? Because cosine and secant are reciprocals, which means if you know what cosine looks like, you just flip it over and it just keeps going, and it's a parabola going back. And this one's down like this, so you flip it over, and that's why it looks like that. And it goes like this. And so sometimes people like to graph these. They like to just graph the cosine, and then they just flip it over and do the parabolas. But that's where that comes from, and that's why they are parabola-looking graphs.
So do we have to have like the other 2 points, or do we just like go on and
Yeah, I'll probably be a little bit more lenient on this one. If there's a number in front, you want to think about that it is going to stretch that more. So, you know, we'll look at some of them. But you're right. I'm much more lenient on these than I am on the other graphs. Because if you know what cosine is, you can just flip it over. We can go ahead and say here that the period for these will also be 2 pi over b. It's the same as sine and cosine. So the only ones that have a different period are tangent and cotangent. Cosecant is going to be the exact same way. We're going to sketch a little graph of this, but maybe on cosecant, let's graph the sine first, and then we'll see about flipping it over, but it's going to be the same kind of shape, except for our asymptotes are going to be in different spots, okay? So let's look at that real quick. And so, just like the other one, when I see cosecant, I think that as 1 over sine of x, which means it's still going to be the same kind of shape as secant, but it's going to be undefined when sine equals 0, which means its asymptotes are going to be like cotangent, right? Because both of them have sine in the bottom. Which means, where does sine equal 0? At 0, at pi, at 2 pi, right? And so just like tangent and cotangent, I think I gave you a couple yesterday, like, did I give you 13 and 14 where you had to match the graph with the picture, like the equation with the picture? The big thing is, look for the asymptotes, because they can throw a negative in there and it's going to look a little tricky. But if you know where the asymptotes are, then that's going to help you pick out which graph matches up with it. So these are my asymptotes, so let's make a graph. Oops. I might have wrote too many S's on this. I do want to say I was grading the homework quizzes that we took the other day, and when you're making your graphs, very, very important that you label something. If you give me a graph and it doesn't have any labels on it, I can't give you credit for that because I don't know that you know the period of that graph. So notice you don't have to mark everything, but you got to give me enough that I know the units that you're going by. So make sure you're doing that. But I know I'm going to have an asymptote at 0, and at pi, and at 2 pi, and at negative pi, and at negative 2 pi. And let's, sorry, go ahead. That's the whole bx minus c step. And on the next slide here, I'm going to kind of summarize that again, and we're going to practice the asymptotes again. Because you're right, that is the most important part, finding the asymptotes. On this one, let's graph sine kind of as the background of this so I can kind of show you where it's coming from. We can make an XY chart just like the last one, halfway in between, and half again, and we can get those decimals. But I feel like, for me, it makes sense here if we look at sine. And plus, it's a nice little jogger memory of sine. At 0, what is the sine of 0? 0, sine always starts down here. And then at pi halves, what happens with sine? It goes up at 1. And then it goes back to 0 at pi, right? It makes that little half parabola there, little parabola going down. And then at 3 pi halves, we go down to negative 1, and we go back to 2 pi, right? That's what sine looks like. And I could do the same thing over here, except for with sine. Sine is odd, so it switches, right? So at negative pi halves, it goes to negative 1, back to 0, up to 1, back to 0. And if you want to label that so that you don't get confused later, that's sine of x. Just like with secant, every single one of those little diffs are going to just flip over for the reciprocal. And so Katie said, do I have to pick all those points? You really don't. I'm going to be pretty lenient here. I'm mostly looking at this point's in the right spot. And we'll talk about things about the amplitude. If there was a 4 in front of this, where do you think that's going to go? Instead of going to 1, where's it going to go up to? 4, because that's what would happen with sine. So that's the big thing I'm looking for. So when you graph these, all you got to do is say, well, I know halfway in between it's going to go up to that height or that amplitude, and it's just going to flip over. And so I'm going to be pretty lenient here and say I can just flip that over and make the parabola going up. Yeah. As long as this point's in the right spot is what I'm looking for. Yeah, and whatever the amplitude is, like the 4 or whatever's in front of it, that's where that could move. You could pick the point and make sure. It always works. Make the XY chart, but you don't have to every time. And the same thing on this one. Halfway in between the asymptotes is going to be my minimum point, which on this one is just 1, and then it's just going to flip down. So it's just going to be like a parabola going down. Again, that's one period. One parabola going up, one parabola going down, and then it just keeps repeating itself. Like this one would go up again. Over here, it's the opposite. So now this one is going to go down, and this one is going to go up. And if you want to write here, the period for cosecant is also 2 pi over b.
What would it look like if there was another?
Like if it was 3 cosecant of x, right? It's going to be the exact same shape, except for instead of going up here at 1, it would start up here at 3, because think about, wouldn't sine go all the way up to 3? So that sine would go all the way up here, so that means flipping it over would go all the way up there, and it would just be up there, and then this one would go down here to -3 and go down. So it's just kind of stretching it out, basically, or moving those parabolas. Negatives are going to have the same effect as in all of these graphs. They can reflect them. So sometimes if you see it down first and then up, that just means the negative is in front is what's making it do that. Okay, so those same rules apply. Asymptotes are the most important thing, because if you don't know the asymptotes, then you're not going to get the graph right. So let's kind of go through how we can find 2 consecutive asymptotes for all these graphs, and then we'll practice at least 1 or 2 of these. So for tangent, and I'm just going to write the bx minus c part. Tangent of bx minus c, and tangent is sine over cosine, so secant of bx minus c. They're going to have the same asymptotes, and how do I know that? Because I think about what's in the bottom, and this is honestly how I remember it. It's how I do it when I'm taking a test. I don't just have it automatically memorized. I think about tangent is the same as sine over cosine, and secant is the same as 1 over cosine. So their asymptotes are going to be where cosine is equal to 0. Yes? So on your homework, anytime you're graphing, if there's something here other than just x, to find 2 consecutive asymptotes, you're going to take that and set it equal to -pi halves, and you're going to set it equal to pi halves, and you're just going to solve for x, and those are going to give you 2 asymptotes in a row. For the ones that you have to graph by hand, there will never be a c value. Like, you're not going to graph those by hand. Could I give you a question with the c value that just says, give me 2 consecutive asymptotes? Yes, because I want to know that you know how to do this. But you're just going to set that equal to -pi halves and pi halves. The other 2 go together also. Cotangent of bx minus c and cosecant of bx minus c. And again, how do I know they go together? Because they have the same denominator, and that's how I think about it. Cotangent is cosine over sine, and cosecant is 1 over sine. So when I'm trying to think about their asymptotes, if I forget the rule, I ask myself, what's in the denominator? What's going to make that undefined? And that's how I remember which one's which. Sine is undefined on the x-axis. So that's why to find your asymptotes, you're going to always set that equal to 0 and equal to pi. And if you solve that for x, that will give you those first 2 asymptotes. And if you can find those first 2 asymptotes, I feel like it's not the worst thing in the world to graph after that. So this is kind of a really good thing. This is not in your book summarized like this, but I feel like it's helpful. summarize it. So let's practice doing this on a couple without actually graphing them, just to make sure that we are good on the algebra here. One day we should just like count to 10 in here in English. Like 1, 2. So number 3 is a problem that I would never make you graph, but I could give you, and I can guarantee, I already know on your test, that there's questions on your test that the directions just say, give me 2 consecutive asymptotes, and there definitely is a C value there to make you do the math. The big question is making sure you know what you set it equal to. Secant is 1 over cosine, yes? So I'm going to set this equal to what? Negative pi halves and positive pi halves, and I'm just going to solve that for x. So if I'm going to solve this for x, you agree I'm going to add pi over here? I can add those together because they both have pi in them. It's like negative 1/2 pi plus 1 whole pi. Do you agree that that's just positive pi halves? You can always do that on your calculator, just leave the pi out of it and then put the pi back in it. And then what am I going to do? Divide by 4. And be really careful on this. We tend to make a lot of mistakes when we're dividing fractions. But remember that dividing by 4 is the same as multiplying by 1/4. So that really would be equal to pi eighths. Yes? Lots of times people just get one and then they automatically say the other one's going to be negative pi eighths. When there's a C value, be really careful on that because it's not necessarily going to be true. Like on this one, when I add pi over, I'll just make that my pi symbol. Pi halves plus pi is not pi halves anymore, right? Like those are both positive. That's going to be 3 pi halves. So make sure you do the math there on those. Divide by 4 is still the same as multiplying by 1/4. So the next asymptote on that one would be 3 pi eighths. Again, those aren't really so pretty. That's why you don't have to graph those. But that's how you find 2 asymptotes. Yep, because they have cosine at the bottom. And then cosecant and cotangent we set the same because they both have sine in the bottom. This is one you could graph. Like this could be on your homework tonight. Graph this because there is no C value. Same idea. You set this equal to the 2 asymptotes that normally it has. And normally cosecant is 1 over sine, so it's undefined at 0 and pi. So I would set 3x equal to 0 and 3x equal to pi. And that's going to give me my first 2 asymptotes. So I would get x equals 0 and x equals pi thirds. You follow me on that? Maybe? On your homework today, more of the same stuff that you did the tangent and cotangent yesterday, only now it's secant and cosecant. So guess what? There's 2 problems just like 2 and 4 that you did yesterday that have secant and cosecant that ask you which one is which. There's also questions on your homework today asking you to use your calculator or use your unit circle to go backwards, just like 31 and 35 that we went over. So hopefully that'll go easier tomorrow. We'll definitely spend some time on the homework tomorrow. Whatever questions we have, we'll spend a good 15-20 minutes on it. And then I have a worksheet for you tomorrow over graphing all of these functions, kind of putting it together. So hopefully we will feel a little better about it. Next week we're going to use the graphing calculators to graph these a little bit. Like we're definitely going to spend another day or so on this next week. But But hopefully tonight's homework will go a little bit better. Do your best to catch up as much as you can if you didn't get any of last night's homework done. But try to graph a few of them and see what's happening. And we'll definitely do a couple of them on the board tomorrow if we need to. I don't know. We'll see. We'll see. I think. Yes. As the last note